Welcome everyone. Question number 21. Castigliano's first theorem is applicable. Castigliano's first theorem, it states that the partial derivative of the total strain energy in a structure with respect to any particular deflection component at a point is equal to the force applied at that point in the direction corresponding to that deflection component. So mathematically we can write P equal to del U by del delta. P is the applied force for which the deflection will be there, and U is the total strain energy of the structure. This theorem is applicable to linearly or non-linearly structures in which the temperature is constant and the supports are unyielding. The theorem says that if we make the partial derivatives of the total strain energy of a structure with respect to the deflection component, then we will get the applied force for which the deflection will be concerned. Now, principle of superposition. In structural analysis, it states that the total effect, that may be displacements, stress, etc., on a structure due to multiple loads acting simultaneously is the sum of effects that each individual load would cause if acting alone. And this principle is valid under when the material behaves linearly and Hooke's law is valid. So the load will be proportional to the displacement, and when the geometry of the structure does not change due to given loading. Let me describe the principle of superposition mathematically. Suppose this is a beam structure subjected to multiple loading P1, P2 and P3, and under this loading the total deflection is delta. Okay, so total deflection delta. And if we consider the beam individually subjected to individual loading, suppose the beam is subjected by this loading P1, that and the deflection will be del 1, and if the beam is subjected to loading P2, the deflection is del 2, and when it is subjected to the load P3, the deflection is del 3. So by the principle of superposition we can write total deflection del equal to del 1 plus del 2 plus del 3. So from the discussions we can say Castigliano's first theorem is applicable when the principle of superposition is valid and when the system behaves elastically. And this theorem is also applicable for statically determinate as well as indeterminate structures. So option B, C both are correct. Question number 22. Principle of superposition is applicable when deflection are linear function of applied forces, right? Because we know by the principle of superposition that the relation between deflection and applied forces for a structure is linear, and the material obeys Hooke's law. So option A, B both are correct. Number 23. In moment distribution method, the sum of distribution factors of all the members meeting at any joint is always. The moment distribution method is a structural analysis method for statically indeterminate beam and frames in which every joint to be analyzed as fixed joint in order to develop the fixed end moment. Then each fixed joint is sequentially released and the fixed end moments are distributed to the adjacent members until the equilibrium is achieved. When a joint is being released and begins to rotate under the unbalanced moment, the resisting forces develop and each members framed together at the joint. So the distribution factors can be defined as the proportion of the unbalanced moment carried by each members. And the sum of distribution factors of all the members meeting at any joint is always equal to 1. Option C is right answer. Question number 24. The carryover factor in a prismatic member whose far end is fixed will be, this is the fixed beam, this is the near end of a beam, and this is the far end of a beam. The far end is fixed here, the carryover factor will be half at this end. If applied moment at this end, at this near end is m, the induced moment at this far end will be m by 2 if the far end is fixed, and if the applied moment is m at this near end, the induced moment at the far end when it is hinged will be 0. So carryover factor will be 0 for this case, and carryover factor for this case will be half. Option B is right answer. Question number 25. The carryover factor in a prismatic member whose far end is hinged will be. Option A is right answer. 0. Question number 26. The moment required to rotate the near end of a prismatic beam through a unit angle without translation, the far end being simply supported, is given by, where EI is the flexural rigidity and L is the span of the beam. Option A is right answer, 3 EI by L. We know the relation moment equal to stiffness K into rotation theta, and unit angle means theta equal to 1, so M equal to K we can say. Okay, so for our case, the far end is hinged, the carryover factor will be 0 as we discussed earlier, but the stiffness at this end will be 3 EI by L, and stiffness equal to moment, so moment will be 3 EI by L at this end to rotate the near end without translation. When the far end is being fixed, we know the carryover factor is half, but the stiffness at this end is 4 EI by L, and stiffness equal to moment, so moment at this end will be 4 EI by L, and at this end will be 2 EI by L. Question number 27. The moment required to rotate the near end of a prismatic beam through the unit angle without translation, where the far end being fixed, is given by. Option D is right answer, 4 EI by L, where EI is the flexural rigidity and L is the span of the beam. Question number 28. If M is the external moment which rotates the near end of a prismatic beam without translation, where the far end being fixed, then the moment induced at the far end is M by 2 in the same direction as M, as carryover factor at the fixed end will be half. Option A is right answer. Question number 29. The principle of superposition is not applicable when the material does not behave linearly and Hooke's law is not valid, and the geometry of the structure changes due to given loading. Question number 30. If the displacement at coordinate I due to unit force at coordinate j is del ij, and displacement at coordinate j due to unit force at coordinate I is del ji, then according to Maxwell's reciprocal theorem, suppose the beam is loaded with unit loading P at the center, and this is the coordinate I and this is the coordinate j of the beam. Okay, at the coordinate I, due to unit loading P, the deflection is del ij, and in second case, due to loading P at the coordinate j, the deflection is del ji. Okay, so by Maxwell's reciprocal theorem, del ij will be equal to del ji. Option A is right answer.